Hey everyone, just to go through a few of our sine and cosine graphs, just if you are wanting to catch up, or if you don't quite understand a few of the notes from the textbook, hopefully I can go through just a bit of a simplified version of the stuff we're going to be looking at today. So here we have our sine graph. So far we're going to be looking at how it sort of is continuous, and it sort of follows the same pattern. So I've only shown really one period of our sine, but it actually keeps going on and on and on and on and on forever. But just to have a look at it today, our period that we've got for us today is between 0 and 2 pi. Now this is just a regular sine of x graph, and so it's got 0, 2 pi, and we actually meet in the middle here at pi. Our high peak comes to a top of 1 in the y-axis, and in the x-axis we've got pi over 2. And at the bottom here, if we come all the way around, we have 3 pi over 2 as our x-axis and -1, which lines up here, as our y-axis. So that's our sine graph. And today we're going to be going through just a few of the transformations that we can do to this graph, just to make it a little bit different. But before we do, I just want to remind us that we also have our cosine graph that we also can look at, which starts a little bit opposite to what we do before. Instead of starting at 0, we start at 1, we then come to pi over 2 as our intersect here. We come down to pi and -1 down the bottom here. So it comes down to a low of that. Then it intersects here again at pi over 3 and 3 pi over 2. Sorry, I'm messing up my words. Scratch that little bit. This part here is 3 pi over 2 and 0 as our intersect. Finally, we get to the end of our period, which is 2 pi as our x-axis and 1 as our y-axis. And then that will repeat on and on and on forever. So just to remember, when we have sine, we start at 0 and on the y-axis, whereas on cosine or cos, we start at 1. If it was a negative cos, we would start at -1. So it would kind of be flipped up the other way. Same with this one. If it was a negative sine, we would just flip it up the other way. So it'd kind of be coming down, follow along, coming up, and then coming back down again. So hopefully you could follow my finger for that one. But we're just going to move through a few of our transformations today. My first one that I've got here is we've got the amplitude. Now I do apologize. I started writing it and I realized I was writing it very messily, so I crossed it out a little bit. But our amplitude increases or decreases the width or the top to the bottom of my graph. So if I have a look at my purple graph, this is my sine graph. So this is the same one that we had before. We've just sort of kept it nice and easy. So we've still got the top is at 1 and the bottom is at -1. If I was to multiply my whole graph, so here we've got 2 sine x, it makes my graph push extra higher. So it pushes all the way up to 2, and then it comes all the way down. And I haven't written this here, but it comes all the way down to -2, and then it comes back up. This doesn't change the period of my graph at all. It just changes the amplitude. So my graph is still the same width, but it's now a lot taller, and it goes a lot deeper as well. All right, here, we're going to also look at the graph of y equals half of sine x. Now, just to work through this one, you might be able to guess what our different amplitudes are. I haven't written them down, but here we have an amplitude of 1/2 instead. So we're going to go from here, it's going to take me all the way up to 1/2, and bring me back down to 0, so they always meet in the middle here. And then we're going to also continue on to be -1/2 here. So if I have a graph that, like my red one here, that has a sort of a larger number in front of the sine, it's going to push my graph out and push my graph down as well. Whereas if I'm going to have a fraction or something a bit smaller, it's going to squeeze it in. Not to be confused with negative numbers, which would then flip it and then change the amplitude. So if it was a negative number, then we'll just treat it as if it was a negative graph. All right, we're going to go through just one more transformation, and then I might quickly pause the video and then we're going to jump into the last two transformations. All right, so our last ones we're going to be looking at today is we've got a period of 2 pi, and we looked at that at our first graph. So we can see on my purple one, this is my regular sine graph, and always on sine, we have a period of 2 pi, which is equal to 360 degrees. And that's because that's just sort of the period of the circle. When we do our math, we can work out that we can change our sine, we can change the period that we have for our graphs in kind of the opposite way that we did with our amplitude. If I have a larger number here, so a number greater than 1, it's going to squeeze my amplitude and make it quite, not squeeze my amplitude, it's going to squeeze my period and make it smaller. So if I have a larger number here, it's going to squeeze the period and make it so it's a lot smaller. So I've multiplied it by 2, so if I multiply it by 2, it's actually going to half the amount that my amplitude's going to be, my period's going to be. It's going to half my period. So I've gone from having a period of 2 pi to a period of pi. Finally, if I had a period of 1/2 here, if I had 1/2 over next to x here, it's going to increase my period. So you can see that my period not only goes to 2 pi, but it keeps going on and on and on and on. And it goes off my page over here. Now we can actually use a bit of a formula for this one. So here I've got my sine of AX, which was going to be my purple which could be my purple graph, but my A is going to be whatever I do to my amount. And my period is just going to be pi, or 2 pi 2 pi divided by A. So I should have put a little 2 pi there, but I forgot to put that one on. So that says a 2 pi over A. Finally, we can now use that formula to work out different things. And you can see I have put the 2 in on these particular ones. So I've got period equals 2 pi over 2. And we pulled that 2 just out of here. So I've gone period for my green graph, which is this one here. The 2, we're going to move it down to the bottom of my equation. And my period equals 2 pi divided by 2, which is just going to give me pi. And you can see that after that, it would just keep repeating itself, meaning that the period would keep going on and on and on and on and on. Finally, let's work through my last one. We've got my period is equal to 1/2 x. So what this is going to do is I've got period equals 2 pi over 1/2. Now this is a bit of a tricky one because we are dividing by a half, which we can then just convert to 2 pi times 2, which is just equal to 4 pi. So this would go all the way out to 4 pi, which is where my period would end. All right, I might go through just 1 or 2 more transformations. These are super easy ones, and these are things that we're going to be covering on Friday in our math methods class. So we've got when we want to add or move our graph up or down. Now this is a super easy thing to do. Similar to all our graphs that we've done so far, if I add 1 to the end, it's just going to move my red graph, which is just y equals sine x. If I add 1, it's just going to move my graph up. On this bottom one, I've got y equals sine of x minus 1, and then this just moves my graph down. So whatever I have as my graph, it's going to move it up by that many places. So I've only moved it by 1 unit. On this one, it's going to move it up, and I've moved it down by 1 unit, it's going to move it down by 1 unit. If it was like plus 6, it would be up 6, so it would start at 6 instead of starting at 1. All right, finally, we want to go through just the last bit. This is where it gets a little bit tricky, because you may remember that when we have a lot of our different ones where we want to move it across, it kind of works backwards. So if we minus our value, it moves it to the right, and I've shown you this today. So what we've got is I've got my purple graph, which is just sine of x. Sine of x minus pi on 2 is, I've got our pi on 2 here. we start there instead. So it's kind of like we're moving the whole graph across. There is a bit of a proof for this, and it is in your textbook, so you can have a bit of a read through that, but I'm not going to go too much in depth today as I don't want to make this too confusing. But we've got y equals sine of x minus pi on half. That just moves my graph over by pi on 2. So that's why it's moved across like that. If it was a plus, I would instead move it this way. So I'd move it to the left. All right, hopefully that all made sense. Sometimes you'll end up with equations where you have to move it to the left, you have to move it up and down, you have to adjust the period, you have to do a lot of the things that we've done today in this video. So what I'd like you to do is I'd like you to practice these skills individually and then see if you can work out how you would adjust those formulas when they're all put together. This is all covered in our textbook. It is covered in, if I go back to, I'll keep the screen the right way up. If we go through and we find it in our textbook, we've got circular functions. It's covered in 14f, so graph of sine and cosine. It's also covered in 14h, which is where we move it to the left or right, and 14i, which is where we move it to the left and right, and we move it up and down. So there's a lot of different things that we can go through. So they're the ones that you want to work through if you want to get really good at graphing equations. 14f, 14h, and 14i. All right, thanks everyone. I'll talk to you soon.